Yo, it's Tony Dubio. Thanks for tuning back in for yet another brief but very descriptive demo of Metapod Neutron Use Case 3, where we're going to take a look at having two virtual machines that are configured in two separate projects, or otherwise known as tenants, two separate tenant projects, and communicating together through a neutron router. In this case, we're going to share a neutron router for two tenants. Now, in practice and production, you probably wouldn't do this, but in a lot of cases for like demos and for sandboxes, it makes sense because you can share resources and ultimately uh, limit the amount of needed public IPs as an example. So, you really can optimize your floating IPs and build these demonstration types environments. So this time, to switch it up a bit, we're going to use the command line, the Neutron command line, to configure this complete environment from start to finish to give you an idea of some of the Neutron commands and what it takes to build the router and to share the router, the virtual router. Okay, you see here we have two term windows open, one pointed to our Cisco Live A project. The second one on the bottom we have pointed to our Cisco Live B project. And in each one of these, we need to do a net create command so that we can create the networks that we want to use in each one of these projects. After creating the network, we need to subsequently create the subnets. So we'll create the 10.1.1.0 subnet, and we will also on router B, or what we will connect to router B is subnet 2, which is the 10.2.2.0/24 subnet. Now that we have a subnet, we also need to create the router. So that would be the Neutron router create, and then the name of the router. In this case, it's the Cisco Live router. The next thing we need to do is we're going to set the gateway for that router, and we need to connect that gateway with the name of the external network. So this would be the routable network that's publicly addressable, and that would be the subnet that we use for our floating IPs. So those netted IPs that provide inbound access from the internet would be a part of that network. So we, at this point, set the gateway. Now we're going to list our networks. And what we're looking for is the actual IDs of those networks. So if you look to the left, we have these IDs that have been provisioned for a specific network, so we can use that to boot a virtual machine. In other words, spawn a virtual machine. So the command nova boot, the name of the image, the name of the flavor. We're going to identify the NIC and the network ID for that specific network, and then the name of the virtual machine. So in this case, we will have a VMA on the A side, and we'll create a VMB for the B side. And that's what you see happening here is the second virtual machine. We're booting that one from that command. Okay, so we can see that we've built both of those. Now what we're doing is, instead of going through the commands of creating a security group, to save some time, I'm just going to modify the default security group so that we can allow ICMP, which will allow us to test that the virtual machines are actually routing between each other on those private networks by being able to ping each other using the security group that will allow the ICMP traffic to pass through the router. So we go in here into the rules, and we can see that we've allowed ICMP traffic. Same thing on the B side. Now what we can do is go into the virtual machine itself from the console and look at the interface. So on Ethernet 0 on VMA, we have a 10.1.1.5 IP address assigned to that virtual interface. That's the 10.1.1.0 subnet. That is the A side network. The other thing we're going to do is look at the default gateway. So we'll issue this command, the netstat-r, and we can see that our gateway is 10.1.1.1, which is the interface in our virtual router. We can also use the internet outbound. So we can use our DNS, resolve, and ping Yahoo in this case. And now what we're going to do is ping that other subnet, the 10.2.2.5, which is the IP address of the virtual machine in the Cisco Live B project, pinging its address and routing through that virtual router. If we toggle over to VMB, here we notice that in Ethernet 0, we have a 10.2.2.5 assigned to that virtual interface. And we're going to go ahead and do the same thing. Look at the route table in our gateway in that same router, but on that B side network is 10.2.2.1, and our default gateway is through that router. So we can, again, ping Yahoo to have outbound internet access using SNAT in that router and resolving that IP address. Okay, and then we're going to ping the 10.1.1.5 address in VMA. And again, we can route across that router from one private tenant network to the other private network to prove that we can share a router. Again, typically a use case could be for demonstration, perhaps in a multi-tenant environment. In either case, it's possible to configure this, from Neutron and leveraging that virtual router. So thank you for attending this session, which is based off of use case B in the Metapod. And please stay tuned and check out the rest of the use cases for Neutron.